you may not ask the auction house in the topic of my presentation. All I knew before about auction houses, before I came to this project, was like, sold for this gentleman in first line for $100 million. And that's all I knew. And I want to just play with you some small game, just to understand how deep you are into the art objects, let's say. So probably everybody knows what is this painting. So it's Mona Lisa, of course. Let's try something more maybe tough and put something more local. Somebody realized? It's very nice. Okay, but not all of them so famous. What about this? Somebody knows? Yeah. So it's American Gothic, yeah. But I like the cosplay of this from Japanese artist Masaki, and it's called American Gothic too. And you should not guess who is it. It's me. This is how some unknown AI artists see me in the world of art. My name is Mikhail Chumakov. I'm senior quality engineer at Actum Digital. And you probably heard a lot of already presentation about vector capabilities and open search, and even my topic contains vector capabilities. I would like to focus in my talk on the things which comes together with these capabilities, on the thing which people don't think about too much, and it is a cost. So just to explain how our system looks like, I want to highlight some parts. The first important part that for the client, the main business is auctions and sales. So they don't want to invest too much, even they have like big CTG group, they don't want to invest a lot into infrastructure and related costs. So for this reason, for example, most of the parts of our system is serverless. So we don't pay for compute all the time. We just pay for what we are using. And data comes from different sources, and this brings problems because we have people who deliver data to our system. Then we have some external data sources with scraping competitors like Sotheby's, Charitas, and so on. Why? Because in auction world, it's very important to see all history related to the object. For example, all biddings we have in the lifetime of some painting or some sculpture, and titles and whatever is important for search. How that data comes to our system? Basically, we have some ETL process which is based on step functions, AWS step functions. Then we have some ingestion pipelines, ingestion processing, and then eventually data comes to open search service. Very important what we are indexing. Basically, the document we are indexing consists from two main parts for us. It's images representing this asset, and metadata like description, title, chart of arts, attributes, and so on. And then from the other side, we have the consumers. It can be client, real people. We have automatic jobs. I will mention it later. And these automatic jobs are really important. Why? Because of data, because of nature, how the data comes to our system, we have a lot of duplicates sometimes. I will explain why later. And we need to detect these duplicates and then merge it somehow. So what is the use case and root cause of our problems? So probably everybody knows Pablo Picasso, but somebody knows this painting from him, or this graphic from him. It's less popular, and this painting particularly doesn't have its own name. So the title can be Minotaur Caressing a Woman, or it can be self-portrait in three forms. So it can be anything. It's basically how the auctioneer or the manager who evaluate the picture put this data into the system. Another important thing, it's metadata about. So we have a set of chart of art attributes. For example, it can be material, it can be technique, in our case it can be subject matter theme, and what is this actually? Is it figures, or it's methodological creatures, or whatever? Manager can provide whatever. Another problem. Auction house, it's a global organization. They have offices in different countries. So for example, this is Raoul Dufy, Fontaine at Hayes painting. And in Spain, for example, it can be, I'm not sure how to pronounce this in Spanish correctly, Proton Fontana. And in France, it can be like this, the title of this picture. Both are valid and they are correct. We should solve it somehow when we are processing this information. Picasso probably is most prolific artist in the world of art. He produced about 50,000 different assets, and one of them is a collection of ceramic, which contains like 1,600 plus assets. And if you try to find something, they don't have its own name, they have just images. And it's really challenging to find whatever you need. The same applies for example, for Monet, what Lily has about 250 paintings, all about what Lily is, also challenging. And the last thing I want to mention is similarity search. For example, Hermes. This probably most of the women would like to have. Women would like to have this handbag. I'm not sure. They are very expensive, and some of them can be sold out. So the client can reach the manager, ask, "Oh, I saw this beautiful handbag. I would like to have something similar. Could you find me or offer me something?" So the manager needs to find something for sale. So how are we gonna solve these problems? So nature of search. Like traditional one, it takes us text as an input, and as you can saw from the previous slides, sometimes it brings some problems. So multimodal search on the other side brings us possibility to search over different models. It can be text, it can be images, it can be video, audio, whatever. For example, Amazon Music actively use audio input as one of the modality. And yeah, lexical search is widely used in all applications around the world, search applications around the world, but it brings some problems. It requires big effort, a lot of expertise to fine-tune the index to provide relevant results. From the other side, vector database allow you bring to your system low latency query and discover a set by the meaning. Fortunately, we have OpenSearch, which give us all these two options in one package. So, if you remember the previous slide, the system, how it looks like at the beginning, we decide, okay, let's deliver semantic into our search application. So what we start to think about? First of all, we are a small team. We don't want to rewrite or change the system a lot. We would like to leverage opportunities of using vector or semantic search with less, like small effort, let's say. So what we did, OpenSearch provides you a really flexible way with ingestion pipelines to connect some external data models, AI models. And in our case, we choose Amazon Bedrock because it offers some fundamental models like Titan, for example, multimodal embeddings. And we read carefully about how to integrate it, how to leverage benefits of it. And it seems like we can do this very fast. And actually, we did it very fast. And deliver basically the semantic to our system. But it comes with some pros and cons as usual. The first things, it's of course benefits we got, easy to implement, very simple. Since Bedrock is absolutely serverless service, so it's fast and scalable, very reliable, easy to manage, and the time we spent to basically deliver the first proof of concept was very fast. Of course, it comes with some drawbacks. So first of all, the Bedrock service is limited by the number of models it's offer. Another thing, it's cost. I will uncover this topic later. How many times usually, like who, first of all, to fine-tune the indexes? Probably most of you here, yeah? So when you fine-tune the index, you basically sometimes can leverage the reindex API from OpenSearch, but it has some limitations. So very often when you fine-tune analyzers or something like that, you need to rebuild index, basically reindex everything from the beginning. And it brings some problems. And another thing, Bedrock is limited with fine-tuning some fundamental models. So the inputs we have database of about 40 million assets. In average, each asset has about 3 images. And let's say, since we are decided to use multimodal approach, we are going to index the object description. And this brings us the cost, which consists from 2 main parts. The cost of image transformation to vector and the cost of tokens, number of tokens we use. So for one indexing, the total cost was for us about $3,400. Is it a lot? The answer is usual, it depends. For some businesses it's nothing, for some businesses it's a significant amount. And I forgot to mention one thing, the total cost of our infrastructure per month, it's about $1,000 per region. So compared to infrastructure cost, it seems like significant amount. Okay, less effort, more money. We start thinking about how we can improve it. Actually, Bedrock offers you another mode, it's called batch mode, or batch processing mode, which is twice cheaper, which is already much better. So, but for that, we need to rewrite our ingestion pipeline. So, and we managed to reduce the cost of one indexing to $1,700, which is not bad. Twice less, twice better, probably. We start thinking about what we can do further. And the next thing, we start thinking, okay, ingestion pipelines were okay. Very easy to use, not too much management and development effort. But let's go with cheaper solution. So what we've changed? We decided to do not use ingestion pipelines anymore. So we introduced our own ingestion logic. What this logic do? Of course, like if we need to reindex everything, let's say at the beginning of the project, we can rebuild indexes, I don't know, many times, like 3-4 times per month. It is a lot, so every time we need to pay this amount for indexing. So embeddings usually doesn't change over the time. We can cache it somewhere because images doesn't change, do not change for an asset usually, but description can be. If it's slight change in the object description, probably semantic will stay the same. But if it's significant, probably caching somewhere, in our case it was DynamoDB, but caching this data, these embeddings somewhere is good, but maybe they will be not actionable anymore. So we start thinking about what can we improve else. And AWS offers you another service which requires already more effort compared to Bedrock, because Bedrock completely managed, serverless, you don't need to care about a lot of stuff. SageMaker from the side gives you more flexibility, but you should take care about your model by yourself, you should choose model, you should train it maybe, fine-tune it, a lot of stuff. And it's way more complicated to set up it compared to Bedrock. But so the system basically stays the same. We just replace the service which hosts the model. And yeah, it gives some pros and cons as well as the first solution. So it's way more flexible. You can train model, you can choose model, whatever you want. Very cost effective, I will show you later. Fine-tuning model, way better compared to Bedrock service. But of course, drawbacks, management effort much bigger, and you cannot, for example, use Titan multi-model embeddings because they are offered only, these models are offered only through Bedrock. And cost. So the cost here consists from different components, let's say. First, you are paying for compute time, and the second, you are paying for data processed. So there is a lot of calculation. Again, inputs are the same. We have 40 million assets, around 3 imagers per asset, and the amount of data we would like to index about 400 bytes. So in total, we got like $168. The data processing cost, I cannot probably, I can omit it, sorry, because it's just $1 basically. So, which is already much better compared to what we had at the beginning. And another like benefits, basically it's valid for all options I showed you. It's solving the problem I mentioned at the beginning, pure taxonomy. And I really like this meme, how far you should go with generalization. So we got embedding vector. So should we stay with this or not? I really like this guy, that Thermal. And this is the quote from his article, The Other Hard Retrieval Problems. And the main point is, should we use just the semantic search, or we need to look to something different? And actually, if you look into the, we'll search over internet, for example, different benchmarks, you can see that this classical lexical search based on term frequency, like BM25, for example, are widely used and very performant in some use cases, even much better than compared to semantic search. And the main problem of approach with just semantic search that it is a poor generalizability of single embedding model. So, fortunately, as I mentioned already, OpenSearch, it's all-in-one package, and we can leverage benefits of both. It's called hybrid search, where we can use the neural or semantic search together with classical lexical search. For example, when the user types like Picasso in keyword, he wants to see Picasso, and not something like semantically similar to this term. So, and it's great that you can use it together, but it brings one problem, and the problem is that semantic search and lexical search calculates the score on different scale. So you have to somehow measure or normalize scoring from both searches. And this is our search pipeline we went through, but briefly, I would like to say that I would say I would expect more from OpenSearch, but for now we have whatever we have. OpenSearch offers you two main normalization techniques. It's called L2 or Euclidean normalization, and it's basically try to magnitude the scale the scores, sorry, and harmonize the scoring across both type of searches. Another strategy, it's min-max. It's basically try to fit scores into some particular range. Usually it's between 0 and 1, where the 0 represents the lowest score in your search results, and 1 represents the high scores in your result. And then both scores from both queries basically normalize to this range. I don't want to go too deep into detail, because here is an amazing article from Lukasz Jeniot. He explained in details how both of them works, with like formulas, with like deep dive to problematics. And I just want to mention that outcomes of this article, it's basically which technique fits good to which use cases. So basically, if you need to rank in documents in search engine, recommendation system, or machine learning, feature square, go with L2. If you, let's say, more classical, if you are solving more classical problems like in commerce, for example, searching by images, processing some financial data, user rating, recommendation system, and so on, general recommendation go with min-max strategy. So our outcomes from this journey, how we were started with decision to bring semantic into our search system from what we got eventually. So we solved the problem partially. Actually, here is written that no duplication because of pure taxonomy, but it's partially true. We still have it because we require manual effort, because we create the our jobs creates the we call it linkings. So basically, it's asking the manager to check if job match two objects correctly, and they are really duplicates, and then manager basically approve it or not. Neural search together with lexical search actually really improved our search relevancy. Even we had like really fine-tuned index. About 50% relevancy, like we improved relevancy about 15%. Another thing we realized that even the fundamental models and what you can get on the market are really good. I will show you in demo. They still need to be fine-tuned. You cannot use it out of the box, even they are already very good. And between choosing service, in our case, from AWS, between, let's say, SageMaker and Bedrock, you should be really careful about cost, because it can be significant. And now I would like to show you some demo I prepared for this based on the data we have. I cannot show you the complete listing because part of them are under NDA, but it is the same data and similar use cases I mentioned. So, for the beginning, I would like to show you how easy to set up the connection to Bedrock from OpenSearch in AWS. Basically, all you need is just to register model groups and create connector to send requests to Bedrock. So Bedrock expect HTTP request. Should I zoom it? Probably, yeah. Thanks. So this is basically HTTP payload Bedrock expect from caller. It's a very simple JSON with input text, base64 encoded image, and then optionally you can tell Bedrock which size of vector you expect as a response. Then connector itself, I think it's well documented, but I just want to maybe highlight here pre-process function and post-process function. It's written in this painless script, and this needed just because we have input data needs to be transformed to the JSON payload Bedrock expects. And then we just need to register the model, and basically that's it. We can test it. Okay. So we got some data back from Bedrock. So a couple more things we have to do. It's ingestion pipeline, which basically were also very simple. We have, I will show the index structure or index settings later. So we need to define to which field put embedding and from which fields take data for processing for inference. And then search pipeline, as I mentioned, we had actually in the presentation it was a small mistake. It was not the weights were different. It was not 0.7 and 0.3. It was in real it's 0.6 and 4. Yeah, and this is our basically search pipeline, and that's it. So now let's play with. Oh, sorry. Let's play with semantic and erotic. And yeah, so in World of Art there is the collection of paintings from Jared French, and most of them don't have like particular name, but auctioneers in jargon call them nude male. So let's, naked male. So this is very simple user interface. It's from Gradio. I use Gradio to build up it. So there are basically 3 inputs. It's text for semantic search, text input for classical search, for lexical one, and image search. So let's play with jargon words. Huh? Can you zoom in? What you want to zoom? The picture? So yeah, actually this picture, this concrete painting has its own name. It's the French island. I don't know why. There are also from René Magritte some painting which also corresponds to the semantics of what we are searching for. Okay, but now let's go to another use case I mentioned. So let's go back to Hermes handbags. So let's imagine we have this handbag in catalog, and that's what our client would like to have. But unfortunately, handbags sold out. So, okay, we have there like a lot of similar. You can see that it's follow the style of handbag. Just try to find something similar with different colors, different maybe materials. And our particular client has some particular requirement. He would like to have something similar, but from crocodile skin. That's where the classical BM25 or classical lexical search can help us. Let's try to search over our catalog for the similar handbag, but from different material. And material in our case is the term search. And we see we can find something similar in the style, but as you can see here, I think you can, here is the material and technique, it's the metadata we index together. We use this in a traditional search, and it's deliver us what we expect. This partially crocodile, probably. So this is a combination. Actually, it works even better together because sometimes manager can put not alligator because both are the same, alligator and crocodile. So it gives us even more results. Now we don't fit only to the handbag style, but something can be something which can be different from what we got at the beginning. So now let's move to the pure image search. So I just want to show you the collection of command we have. They are different, but I would like to focus on this, the first one. I would like to remember, I would ask you to remember the blazon in the middle. It's more rounded. And this is very similar command. With the blazon at in the middle, it's more kind of rhombus. For image search, very important the image quality. So let's try to find the similar, something similar from catalog with the image with good resolution. And notice this is different angle, so it's not the same picture. And we would like to focus on details. So, and you can see that this command, oops, wait. Exactly, we are, on the first place, exactly what we are searching for. So it's the same command with the same blazon in the middle. And the very similar one goes to the second place. And let's check what will be if the image quality will be bad. So it's the same image, but with low resolution. And you see we start losing some details. So for example, the AI model cannot recognize anymore, or so a semantic search cannot recognize anymore some very important details for us, for example. So actually the command we are looking for moved to the second place. The situation became really even worse if we are working with black and white photos. So I will show you the good resolution. It's a part of the it's a photo part of this the same command we just used for the search. So even by the handle we can still find it. But if we will use the same photo in black and white, so we lose a lot of detail. So we lose the color of the wood, we lose the texture of the wood, and now the results are terrible, actually. So we see whatever we have in catalog, but not the command we are interested in. So this is just 3 use cases. I show you how you can use the semantic text search, image search, or a combination of them together with lexical search. And we don't have too much time for more demos. And oops. And I would like to finish actually my presentation with this quote again from Doug Turnbull. And for me, it's very important, actually. And when you are bringing something to the system, like you would like to use semantic in your search, it's good. And this is not a problem at all right now. The main problem is everything around. It's a cost, taxonomy, data quality, infrastructure around, and the way how you fine-tune the indexes. Saying that, I would like to thank you. I hope you found this interesting, maybe got something useful for your good future projects. Thank you.
We have time for questions.
I was at the AWS Summit some time ago, and I talked with an AWS engineer, and I asked about OpenSearch Server.
Oh, I'm sorry.
Microphone.
No, it's for the recording. Sorry.
Hello. I was at the AWS Summit talking about OpenSearch Serverless on AWS, where we also got a response from AWS that it's extremely expensive, especially on production clusters. Is that something you also looked into, or are you using the on-demand?
We are not looking into this for a couple of reasons. Because to keep it warm up, and running all the time, you have to have at least one instance running, because the index should be, it takes time to upload index in the memory. This is first problem, and the latency for us is critical in this case. And the second problem, I didn't mention this on the first slide when I showed you the infrastructure we have. Actually, it's multi-regional infrastructure, because let's say 3 years ago, AWS experienced the regional outage, so the whole region went down. So even you have like 3 zones in one region, it will not help you. So we have the second standby replica of our infrastructure in different region, and it's basically we have DNS failover record, which tracks with health check, which tracks if the system is up and running. And if not, it's automatically switched to all requests to the secondary region. And unfortunately, for some reason, OpenSearch Serverless doesn't have this feature. Even they state that, oh, it's like very reliable, resilient, and so on. We cannot rely on the fact that the whole system just in one region, because for business, it's critical to have system up and running all the time.
Okay, thank you.
I have a question for you, actually. Not as a moderator. I have to. Okay, now that's me, not the moderator.
There was one more.
Oh, was there another question? I'm sorry. You get through.
Yeah. Oh, sorry. Yeah. Hi. I noticed that you were showing a painless script where you were, I guess, making changes to the data and then sending that over to Bedrock. Mm-hmm. I just wanted to know maybe what your experience was with having to debug that, and like maybe did you consider also not using painless in that part?
For the debugging part, I would remove the less part of the word from this. It's pain.
So are you aware of well, first of all, RRF is in the current version of OpenSearch, so that's a third algorithm for combining for hybrid search. And we also have we've published a script on GitHub to optimize your balancing and the different parameters of hybrid search if you have user behavior data. So if you know what a good result is, you can use that to tune your hybrid.
Yes, and moreover, I didn't mention this because we had no time for like complete demo. You can play with these weights, and they give you very different results between on the numbers. And sometimes we realize that we have, let's say, we know our users, so we know some typical query they use. I wouldn't say it's completely query writing, but depends on the query and use case, we track the user behavior. We are using different search pipelines with different settings. This is only one way how we found how to adjust, let's say, search results. But it's just very important. You can have not just one search pipeline. You can have multiple of them.
All right, I think that's time. You can meet outside if you have follow-up questions. Thank you again.